do today. And then, like I said, if we have any time left over, we'll go back and maybe not do all of any problem from the homework, but get you unstuck if you're stuck on one or two. First, I want to look at number 34. And it's pretty straightforward and easy compared to the other two. Number 34 just says rework number 39 for a different shaped package. Not 39, 33. So let's read 33 and then what shaped package we're supposed to use in number 34. In 33, we have a rectangular package to be sent by a postal service and have a maximum combined length and girth, that's perimeter of a cross section, of 108 inches. Find the dimensions of the package of maximum volume that can be sent. That would be very important if you were a company, a business that had to ship a lot of things, or maybe you were making shipping containers. There is a size limit on packages that can be sent through the mail without a big expensive surcharge. So we want to be able to send this package through the mail, but we want it to hold as much as possible. So we want to maximize the volume. Now, the only difference between 34 and 33, 34 is a rectangular package, 33 is a rectangular package, 34 is a cylindrical package. That means its cross-section is a circle. So let me draw my very best cylindrical package. I can only do that because my husband orders a lot of fishing rods in the mail. I know what a cylindrical package looks like. And what is it that I'm trying to maximize?
The volume.
The volume, how much I can put in this package. Normally I have written my primary equation down first, but here actually I just want to write my secondary equation down first because I can do it more quickly than my primary equation. My secondary equation has to do with the fact that there's a restriction on the combined length and girth. And the girth is the distance around the section. So actually, or the package, it would be the circumference of the circle on the end of the package. That's the girth. Let's say that this circle is going to have a radius of r, and the whole package is going to be of length L. Then what is it that must be 108?
2 pi r plus L.
All right, I have to have the circumference of the circle, and the formula for circumference of a circle is 2 pi r, and then one length has to be 108 inches, or can be at most 108 inches. Now, I know the volume of this package is going to involve both the length and that radius. I know my volume formula is going to have two variables in it, and I know I'm going to have to get it to the point where it has only one variable in it before I differentiate it. So just thinking ahead a little bit, I'm going to go ahead. I could solve that for either R or L. Looks like it would be easiest to solve for L. The length has to be 108 minus 2 pi times whatever the radius is. And that's my secondary equation. Any questions about that equation?
How do you know how to solve for L again? Because we were
because we're looking for the length, or?
Not, I think, Kayla, you mean not how to solve for L, but why to solve.
Yeah.
Why solve for L. Right here, I pretty much flipped a coin and said it would be easier to get the L by itself than the R. I know that the formula for volume, that's going to be my primary equation, it's going to have both R's and L's in it. I just have to change one of them to the other.
Okay.
So I thought it's easier to get the L by itself than the R.
That's what confused me last night's homework. Which one to solve for? I was confused. Like, why would it matter?
It wouldn't.
To solve for?
It would not technically matter whether we solve this for R or L. So I usually look for, in some cases, one is easier than the other. Some cases, just flip a coin. It's equal difficulty either way. Here, it's definitely easier to get L by itself than solve for R and have to divide both sides by 2 pi.
Okay.
All right, so that's my secondary equation. Let's work on that primary equation. Volume of a Rott circular cylinder is not something that I expect you just to wag around in your head every day. If you know it,
R squared L.
if you know it, that's fantastic. If you don't, you can look it up. The volume of a Rott circular cylinder is pi times R squared times L, which does make perfect sense if you think about it. What does the pi R squared give you?
The area
Area.
of
The area of the circular end. You multiply that area. It's like the length times width of a square. It's the area of the end. So you multiply that area times the length, and that gives you the volume. So it does make sense, but I would give it to you. The only thing I refuse to give to you, and unfortunately it did trip a couple people up on the test, the formula for volume of a cube. I had a couple people write me notes. You said you would give me formulas, but if you know volume equals length times width times height, and it always does and always has been, and you have a cube, all 3 edges are equal, then it's just x times x times x, or volume equals x cubed for that volume of a cube. This one I would give you, let's see, what would be next now that we have a primary equation? Well, I don't need it to have 2 independent variables. So I need to put, and I didn't mean to use a lowercase l and an uppercase L, but I'm going to put that expression 108 minus 2 pi r in the place of L so that my primary equation only has 1 independent variable. And if I were to differentiate right now, what would I have to use? The product rule, so it might be easier if I distribute that pi r squared and don't have to use the product rule. V equals 108 pi r squared minus what?
2 pi squared.
pi squared or 2 squared.
Yeah, I was just making sure you'd pick up the pi squared. Pi times pi is pi squared. R squared times r is r cubed. Pi squared's a constant, just like 5 squared's a constant, or 3 squared's a constant. It's just a number. So, now what? Set that equal to 0? No, we're not trying to find a package with a volume 0. We're trying to find a package with maximum volume. And to maximize something, you have to look at its derivative. So find the derivative of the volume function with respect to r. And what would that be? 216 pi r minus, oh, bless you.
6 pi squared r squared.
Yeah, 6 pi squared r squared. That pi squared is about 9. 9 times 2 is about 18. You just need to multiply that 18 times 3 to get 6 pi squared, and then subtract 1 from the exponent of the r. That didn't make as much sense out loud as it did in my head, but I thought someone might be wondering, why don't you multiply the 3 times the pi or something? 2 pi squared's the whole coefficient. You just need to multiply that whole coefficient by 3. That gives you 6 pi squared, and then subtract 1 from the exponent. All right, now what are we doing? Now we set it equal to 0, and we're looking for the critical points. So we could factor a 6 pi r out of both terms. That would leave us 36 minus pi r. And when we set 6 pi r equal to 0, what solution does that give us?
R equals 0.
Do you think a package with radius 0 is going to maximize the volume?
No.
Probably not. That would be a flat package. The only thing you could mail in that is flat Stanley. Set the other factor equal to 0, and you would get r equals 36 over pi. That's the exact answer. It's about 11.5-ish. And the units we're given here are inches. So that radius is about 11.5 inches. I'm fairly certain that that maximizes the volume, just like I'm definitely certain that 0 would minimize the volume. But just to be sure, so I don't blow up any rocket ships, I could put 36 over pi on a number line, or about 11.5, and look at the sign of the first derivative to the left and to the right of that. For example, if I put 11 into the derivative, I would have a positive times 36 minus pi times 11 would still be positive. But if I put 12 into the derivative, I'd have a positive times 36 minus 12 pi. That would definitely be a negative. So 36 over pi is where the volume stops increasing and starts decreasing. Therefore, the max is at 11.5 inches, or 36 over pi to be exact.
So do you want the answer to be 36 over pi or 11.5?
If I don't specify on a test, I take either one. The only time that I count off on a test is when I've specifically said, give the exact answer, and you don't. And the only reason I do that is because you don't even have to know calculus to get the 11.5 on your calculator, but you have to know calculus to get the 36 over pi. So that's why sometimes I ask for exact answers. I want to know that you know how to do it, not just which buttons to punch on the calculator. That maximizes volume. And then let's see what we were asked. That may not be the only thing that we were asked. Find the dimensions of the package of maximum volume. Well, 36 over pi is the radius.
How would you write that dimension? Like, what by what?
I would write R equals this and L equals that. Where are we going to get the length of the package?
Plug it into your secondary after you've got L by itself.
Yeah, look for the equation where you solved for L. L equals 108 minus 2 pi r. So L equals 108 minus 2 pi, and just put 36 over pi in the place of L. The pi's will cancel. You have 108 minus 72. Is that 36? 108 minus 72. Yeah. And both of those units are in inches. That's our yay, optimization problems are not so bad problem for the day. The other two just take work. I'm not going to say any particular step is difficult, but I've worked these two problems this morning and they're long. They're just very long. Any questions about 34 before we go on though? Yes, ma'am.
This is a crazy question, but
That's
how do
okay.
you know which one is your primary equation, which one's your secondary equation?
Primary equation is always what you're trying to maximize. Because the problem said maximize the volume, my volume equation was my primary.
Okay, so like if when it says maximize volume, you just your primary equation would be the volume of whatever it is.
Always.
Okay.
Yeah.
Like, and if it wasn't an area, your primary equation would be the area of the.
Always. Yep. Whatever you're trying to maximize or minimize, that's always your primary equation, and it's always your primary equation that you're going to end up differentiating.
Okay.
All right, so let's look at number 40. An industrial tank of the shape described in exercise 39 must have a volume of 4,000 cubic feet. All right, so once again, we have to go back and look at 39. 39 says a solid is formed by adjoining two hemispheres to the ends of a right circular cylinder. You know what that would look like? I have a propane tank in my backyard. It looks pretty much like this with hemispheres, round ends. So here's the cylindrical part of it, and then let's see. This is not going to be pretty, but that's. There's my very best tank. It's a right circular cylinder. I'm not going to write right circular. I'm just going to say it's a cylinder.
What does that even mean?
Plus a sphere. Two hemispheres make a whole sphere. So basically, we just have a right circular cylinder and a sphere. If we want the volume of that tank, we're just going to add the volume of the cylinder to the volume of the sphere. If we want area, surface area, we're going to need to add the surface area of the cylinder to the surface area of the sphere. All right. It's amazing to me that to do this problem, to find the dimensions that will minimize the cost, we're only given one number. The only number in that problem is volume equals 4,000 cubic feet. Everything else, we have to come up with it. What would be a formula that would give me that volume? This is going to be my secondary equation because it's not my volume that I'm trying to maximize or minimize. It's actually my cost. So, but this is my secondary equation. What would be the volume of that tank?
You mean the equation that we
Yes, the equation.
pi r squared plus pi r squared height times pi r squared.
Yeah, it just depends on whether the tank is standing up or laying down. If it's laying down, you probably call it length. If it's standing up, you probably call it height. Absolutely doesn't matter. I called it length, just like I did in 34. But the volume has to be, I'm going to say volume of cylinder plus volume of sphere. If I use that notation, I won't have to write cylinder and sphere so many times. The volume of the cylinder is the same thing it was in number 34, pi times r squared times the length. And then look up the volume of the sphere if you need to. It's 4/3 pi r cubed. And I know that when I get my formula for cost, the cost is going to depend on what two things? The cost of materials is going to depend on what two things?
How much each one costs per square.
Okay, I didn't say that as well as I should have. Let me try again. The cost of materials, the total cost of materials is going to depend on the surface area, how much metal it takes to build this tank. So what two quantities is the surface area going to depend on?
The surface area of the sphere and the surface area of the cylinder.
And what determines the surface area of the sphere and the surface area of the cylinder? Somebody say length and radius.
Length and radius.
Length and radius. The length and the radius are what are going to determine the surface area, and then the surface area is going to determine the cost. So my cost formula is going to have both R's and L's in it. I might as well go ahead and solve this either for R or L. Just Kayla, once again, it'd be a whole lot easier to get this L by itself than, it'd be pretty nasty to solve that for R.
So is that your primary equation?
Not yet, because the problem doesn't say maximize volume. It says maximize, or actually minimize cost. So I don't have my primary equation until I have a cost equation. This is just all leading up to that. This is what it has to equal 4,000. And it would be much easier to solve that for L than for R. I just have to solve it for one or the other so I can substitute that into my primary equation when I get ready to do so. So to solve for L, let's see, I'd have to subtract 4/3 pi r cubed and then divide by pi r squared. That's pretty ugly. What can I do to make it less ugly?
Factor out a IR?
Put them as in.
There's two ways to think of it. Both of what you were thinking would be a way to do it. John said just break it into two fractions and simplify each fraction. That's perfectly fine. Kayla says factor out a GCF so that you can cancel it with what's in the denominator. That's fine as well. Just so happens that's not, neither one of those is what I was thinking first, but that's okay. I was thinking clear out the complex fraction first, and then my second thought was what John said. Break it into two fractions and simplify. But factoring out a GCF in the numerator would end up being the exact same thing. All right, so I'm going to clear out the complex fraction and have 12,000 minus 4 pi r cubed divided by 3 pi r squared. And then if you break that up into two fractions and simplify it, the 12,000 over 3 pi r squared would simplify to 400 over pi r squared. And then the second term would simplify to 4/3 r. 4 r over 3, that's the same thing.
Wouldn't it be 4,000 over?
Oh, that is 4,000 instead of 400. Yes. 12,000 divided by 3 is 4,000. And then the second term is 4r over 3. So that's ugly, but sometimes life is ugly. Personally, I'm impressed that we got such a complicated looking equation when we were only given one number. In the whole word problem, there was only one number, and then here we have a fairly complex expression for L in terms of R. And then I have to go read the problem again because I've already been working half a day and I've forgotten what it is that I'm doing. That's going to be my secondary equation. But let's see. What does it say? Oh, we are given some other information about the cost. The hemispherical ends cost twice as much per square foot of surface area as the sides. The cost is definitely going to depend on the surface area of the whole thing, and for some reason that I don't know, it's more expensive to build the ends than it is the middle.
Maybe it's the work to round them.
Quite possibly, the amount of work involved in curving it. I don't know. Before we can come up with a formula for cost, what are we going to have to come up with a formula for? Surface area. All right, so we're going to have a surface area formula for this tank. Well, the surface area is going to depend on the same two things that the volume depended on. It's going to depend on the radius and the length of the tank. So I'm going to say that total area is the area of the cylinder plus the area of the sphere. Just like here, I said the volume of this tank is the volume of the cylinder plus the volume of the sphere. And then I can just look up formulas for area of a sphere, surface area of a sphere. And surface area of a right circular cylinder. Surface area of a cylinder is 2 pi r times the length. And surface area of a sphere is 4 pi r squared. I'm copying that straight out of the back of the book. I've mentioned this to you once before, but look how cool this is. I'm still amazed by it. The volume of a cylinder, if you take the derivative of the volume of the cylinder with respect to R, what does it give you?
Gives you your area.
2 pi r L. What about taking the derivative of the surface area of a sphere?
Gives you your area.
4 pi r squared. Just pretty darn cool. What do you think we need to do now that we have a formula for surface area of a sphere?
Plug in the information for L.
I think so. I think we need to get that in terms of only one independent variable. We need to either get rid of the R or the L. Maybe that's why we solve for L right here. So I'm going to go ahead and plug that big, ugly expression in the place of L in the area equation. 2 pi RL plus 4 pi R squared.
You took 2 pi r out of 4 pi r squared. Never mind.
No, I
Never mind.
took,
Never mind.
oh, you got it?
Yeah.
Okay. I know I can clean that up some.
You got 2
I'm going to distribute the 2 pi r and see what happens. Well, first term, 2 times 4,000 is 8,000. The pi's would cancel, and r goes into r squared and leaves r to the first in the denominator. Second term, 2 pi r times negative 4r over 3 would be negative 8 pi r squared over 3. And then I have my 4 pi r squared.
Okay, we never did find the derivative because we're trying to minimize, right?
No, we haven't found the derivative because we don't have our primary equation yet. Our primary equation has to be about what? What is it that we're trying to minimize? Cost. And we don't have a cost function yet. We're still working on the area function. I know. And that's why you have to write some words. I need words to tell me this is about my volume, this is about my surface area. I still don't have my primary equation. Now there is one other thing I happen to notice I can do to clean this up. I have like terms. I have 8/3 pi r squared and 4 pi r squared. This is just a little bit easier if I combine like terms. 8,000 over r, and 4 is 12/3, so that's negative 8/3 plus 12/3 is negative 4/3 pi r squared. Let me double check that. Yes, negative 8 plus 12 would be positive. Thank you very much. That's a very looking 4/3 pi r squared. The pi in the middle looks drunk.
What number is this?
You cracked me up.
I'll find it then.
No, I showed you. Do you see it now? It's number 40.
Got it.
Okay. All right. So finally, we have a formula for surface area that only has one variable in it. That's a good thing, but is that what we're trying to minimize? No. We're trying to minimize the cost. Man, I just realized something. It's okay. This is going to happen to you in your homework. But because the ends and the middle don't have the same cost, we may have to go back to, well, actually just one line. This is all the, before we combine like terms, this part of the area was the area of the cylinder. This was the area of the sphere. And they don't have the same cost, so maybe we should not have combined like terms yet. But that's okay. It's only going backwards one line. We're not told what the cost of the middle or the ends is. We're just told that the end material costs twice as much as the middle material. What do we do about that?
Set them equal to each other.
Multiply that.
4 pi r squared equals 2.
Harriman, I hear somebody thinking, but I can't tell what you're saying. Speak a little bit louder and let me hear your idea.
Can you do 4 pi r squared equals 2 whatever in the parentheses? No?
4 pi r squared.
Would be the sphere, right?
Uh-huh.
That's what's 2 times more.
That is going to cost twice as much as the cost of materials for the cylinder.
Right. So you, never mind. I guess not. I guess I don't know what I'm thinking.
You know, sometimes it helps to think out loud. Sometimes my thinking is more clear when I say it out loud. So that's not a bad thing to do. Let me make a suggestion to you. If I introduce another letter in this problem, but it's not a variable, it's just a number I don't know. For example, cost. I could use C for cost. I've already used C for cylinder, so I don't think I want to use C, but what if I use K for cost? As long as I'm introducing a K, which is not a variable, it's a constant, I don't know, what's the derivative of K going to be? A derivative of constant would be 0.
Oh.
Let me write this down. I have an idea. Let K be the cost of materials for the cylinder. Then what would the cost of the materials for the sphere be?
Q. I don't know.
Just 2K.
Oh.
Twice the cost of the material for the cylinder. So 2K is the cost of materials
I have a
for
dumb
the
question.
sphere. Yes, sir.
What I was trying to say was the sphere is 4 pi r squared.
Okay, be a little bit more specific there. It's not the sphere is the surface area of the sphere is 4 pi r squared.
Right. But if we just
Okay,
figured out,
yeah.
we just figured out cost in the step right before 8,000 over r plus 4/3. Yeah, that step. If
Yes,
the-
right here.
If what's in parentheses is the cylinder and then you're adding the sphere, can you not use those as the 2 separate things and set them equal to each other since one is twice as much as the other?
Okay, here's where not speaking precisely is getting you, is causing you trouble. You're saying this is the cylinder, this is the sphere, and that's not adequate because the cylinder and the sphere have a lot of different properties. There's volume of the cylinder, volume of the sphere. There's surface area of the cylinder, surface area of the sphere. There's cost of the cylinder, cost of the sphere. So you have to be a little bit more specific. When you say set these equal to each other, this is the area of the cylinder, this is the area of the sphere. Do we know that those 2 areas equal each other? No. We don't know that those equal each other. What we do know is that the cost of the materials for the cylinder, well, let me say it the other way. The cost of the materials for the sphere is twice as much as the cost of materials for the cylinder. Notice it wouldn't have been adequate here just to write let K be cylinder and let 2K be sphere. That's not adequate because I don't know what about the cylinder and the sphere you're talking about. You have to be more precise than that. And so, without knowing what that cost is, we've introduced another constant and then said the cost of the materials for the sphere is twice that. Now, forget this whole problem for just a minute. Let's say I'm building a box that is made of 12 feet of cardboard, and the cardboard, for some crazy reason, is $2 a foot. There are 8 feet of cardboard, $2 per foot. What's the cost of that box? $16. So you're telling me to get cost, you multiply the square foot times the cost per foot. Is that what you're telling me? And do you see how important it is that you say that out loud or think precisely? You can't just say cylinder plus sphere. You have to say cost of cylinder plus cost of sphere. In other words, before I combined like terms right here, I had the area of the cylinder. What would give me the total cost of the cylinder if I multiplied this by what? By K. What would give me the cost of the sphere? If I multiplied this times 2K, I would have my cost equation. And finally be ready to differentiate something. I know. Here's my cost equation. K times the surface area. I'm going to write it this way. The total cost is the cost of the cylinder plus the cost of the sphere. The cost of the cylinder is this surface area of the cylinder times K. So C equals all that stuff in parentheses times K. That's the cost of the cylinder. I need to add to that the cost of the sphere. Tell me where to get the cost of the sphere and use all the necessary words. 4 pi r squared is the area. Times the cost of materials for the sphere is 2K. So 2K times 4/3 pi r squared. 8/3, sorry, 8. 4, I see it now, 4 pi r squared. I'm all over my paper now, but I just multiplied the area of the sphere, 4 pi r squared, by 2K, since this material costs twice as much as that material. Lot of fun. But we do have a formula for the cost in terms of only one independent variable. R is my only independent variable. K is just some constant I don't know. Now I need to decide, do I want to go ahead and differentiate in this form, or perhaps I'm still wanting maybe to distribute the K's and combine these like terms. I'm not 100% positive that's the best thing to do, but it seems like a reasonable thing to do. 8,000 K over R minus 8 pi K over 3 times R squared plus 8 pi K R squared and then combine these like terms. That's 24 24 minus 8 is 16. 16 thirds pi k r squared. Let me double check that. 8 is 24 thirds. 24 minus 8 is 16. It would be positive 16 thirds pi k r squared. And I wrote that first term as 8,000 k r to the negative 1 just so I didn't have to use the quotient rule. All right, I don't want to do anything else until I make sure that nobody is lost here. Anybody need to ask a question specific? Not, I don't get this or I don't like this, but I specifically don't get how you got blank.
Are these going to be as involved as what's on the test?
Do you want to be an engineer? Are you a future engineer of America or no?
I don't know after this class.
This would be the simplest engineering problem ever, because engineering would have to take into account a lot of other things like the stresses on this tank. No, I can't, honestly, I cannot put a problem this difficult on the test unless it's a one problem test. And I'm never going to do that to you. I felt bad giving you an 11 problem test, but I knew that was all that you could get done. So yes, this is harder than you would see on a test, but if you're an engineering major, you'll look back at this someday and go, I can do that in my sleep now.
Well, what about the computer programs they got to do all that crap for them?
Yeah. That does help, but those of you who are saying...
I know a few of them, and they don't really have to do too much at all. They got them computer programs to do it for them.
You know what? They had to do it to get the degree, to get the job. I promise you that.
This isn't your master's
Yes.
degree.
This sorts out those who can be engineers from those who can't. Or those who could, but would be crazy, and so they just changed their majors. I almost changed my major to PE, right about here.
They can always work underneath an engineer.
Okay. All right. So the answer to your question is no, it cannot be this hard on the test, but you're getting an idea of what what a simple engineering problem would look like. And what I hope that you see is how important it is to be precise with your words. You can't say cylinder plus sphere equals 4,000. That makes no sense whatsoever. You have to talk about, what about the cylinder and what about the sphere is 4,000? All right, let's go back to here. We finally have, guess what? This is our primary equation. It took us a year to get it, but there it is. And again, I'm going to say how astounded I am from the fact that that problem only had one number in it, but yet we came up with this formula for the cost. Now what? Yeah. We're looking for the derivative of that, and remember that k is just a constant. The derivative of the cost with respect to the radius would be what?
8,000 k r negative 2.
Negative 8,000 k r to the negative 2, or I'm going to go ahead and put the r squared in the denominator. Plus what? 32 thirds pi k times r to the first. And then what? All right. I can see what would make it undefined would be R equals 0, but I don't think we're talking about a 0 radius tank here. So I'm pretty sure I can eliminate that as a critical number. I need to know what makes it 0, and how do you solve an equation that ugly? I have two different ideas of how I could solve it. What's your idea?
You could factor out an R.
Set the numerators equal to 0.
But there's something I would have to do before I could just set the numerator equal to 0. I don't have a numerator yet. I have two different terms. I'd get a common denominator and add those. You know, all along we've been saying single fraction. This is why. It's a whole lot easier to set a single fraction equal to 0 than those two terms separately set equal to 0. So the common denominator would be r squared. I just have to multiply that by r squared over r squared, and then I could write it as a single fraction. The numerator would be negative 8,000 k plus 32 pi k r cubed.
You're doing about the 3.
I'm leaving it in the denominator. Well, actually, if I leave it in the denominator, I just saw something. If I leave that in the denominator, I'm going to have to say that LCD is 3r squared and multiply this first term by 3. Negative 24,000 k over 3r squared plus that over 3r squared. Let me double check my work before I answer any questions for anybody. Does this reduce back to give me this?
Yes.
Yes, it does. Does this reduce back to give me this?
Yes.
Yeah.
Yes? I just wanted to be sure. I don't want to make a mistake and go on another hour and then find that I made a mistake on line 2.
Okay, where'd you get the r cubed? I know you.
Why did I use r cubed instead of just r squared? Oh, no. I used 3r squared for the LCD. I got this r cubed when I multiplied that term by r squared over r squared to get the common denominator. It wasn't r to the first. I had to multiply it by an r squared to make it have the same denominator.
Okay.
So a single fraction that's a single fraction set equal to 0. And what has been our other guideline, not only a single fraction, but we've always tried to write our derivative as a single fraction factored completely as possible. That will be easier to set equal to 0 if I factor it. Can I factor a 32 out of a 24,000, or am I just going to have to be happy with 8? Let me factor out a 32 pi k.
Oh, the 24,000 don't have a pi in it.
You can't factor out a pi.
Oh, I can't factor out a pi. I can just factor out a 32k. And that will leave me a pi r cubed minus what? 750?
Yeah.
All right.
Would be negative pi r.
Let me double check.
No way. Okay, you're taking the negative 750 is from the 24,000.
Yes.
Okay. Never mind.
So far, so good? I am pretty sure the cost of this material is not 0. I mean, I could set 32k equals 0, but I'm pretty sure that the cost of material being 0 is not an option. So really, it's the pi r cubed minus 750 that I set equal to 0. Add 750 to both sides. And then divide both sides by pi. And then take the cube root of both sides. Anybody getting about 6.2 feet? Whew, hallelujah. We missed this one. I was just going to walk away. This is just an incredibly real-life problem. Probably a fairly simple real-life problem to anyone in the field of engineering. All we did was figure out how big around the tank needs to be in order to minimize the cost. Now, we probably are asked for length and radius. Let me see. Number 40 says find the dimensions that will minimize the cost. Just so we have time to set up this other problem, we're not going to find the length. But if I was going to find the length, where would I find it?
Secondary equation.
Way back here where I had L in terms of R. And I'd use the exact answer, cube root of 750 over pi, in place of both of those R's, and it would take me another 10 minutes.
So you didn't do any calculus at all?
A little bit.
I took the derivative right here.
That's it.
Oh, yeah.
This one line is the only calculus in the problem. All the rest of it's algebra. And I'm telling you, once you've taken 4 semesters of calculus and you have 4 3-inch notebooks full of paper that look like this, you'll feel smart. And you'll tell your teenage children, shut up, I'm smarter than you. I have notebooks to prove it. All right. I don't feel bad about giving you a problem like that in the homework. I would feel bad about giving it to you on a test. I just would not give it to you on a test. I'm not sure any Calculus 1 student would get it right. All right. One more. Is number 44. And you have a diagram given to you that has to be given to you because it uses variables that aren't defined in the words. 2 factories are located at coordinates negative x0 and positive x0, and their power supply is at 0h. That wouldn't make any sense unless they gave you the picture. So here is some origin, and one of the factories is x units, let's say that's west, x units west of the origin, and one of the factories is x units east of the origin.
Those factories. Okay.
Yes, those factories. And their power supply is somewhere on the y-axis.
That's probably north.
That's probably north. And there's probably a creek in between the power plant and the factories. I don't know, I'm making that part up. Let me draw this picture. Here's some factory to the west, factory to the east at coordinates negative x0 and positive x0, and some power plant on the other side of the river at 0h. Find y. Look back at the picture in the book. Y is the distance from the origin to where the power lines have to branch off and go to each factory. At some point, the power line coming from the factory is going to have to split off in two different directions if it's going to supply power to both factories. So y is the distance from the origin to the split. It's going to come down the y-axis just a little ways and then split off to provide power here and here. And y is the distance from the origin to the split. So what's this distance from the power supply before the split?
Okay, is y a distance or is y angle?
Y is a distance. The distance from the origin to the split.
Is it h minus y?
Absolutely. If the power plant is located a distance h from the origin and y is, or the split is y from the origin, then that distance is h minus y. And so I'm going to have this piece of cable, and then I'm going to have these two lengths. This length going to the plant on the east, this length going to the plant on the west. We're trying to find y so that the total length of power line from the power supply to the factories is a minimum. So I need an equation for total length of the power line. In terms of h and x and y, h and x are some constants. The factories are already built. The power company's already built. The only thing that's a variable here is the y. I'm going to write that down somewhere. Y is a variable. Actually, it's a variable that I'm in charge of. H and x are constants. I cannot move the plants in closer to the origin. So what's a formula for total length of the power line if I call it, let's say, L for length?
H minus y plus x
All right.
plus y squared. Does that work?
Ooh, that sounds interesting. Let me think about your x squared. What did you say?
X squared plus y squared.
You're so darn
Or
close.
the square root. of
Square
x-
root of. Square root of. Look at this. Awesome. This distance from the origin is x. This distance from the origin is x. So we have two triangles with one leg being x and this leg being y. These two power lines are hypotenuses or hypotenae, not sure which is correct, for those two triangles. So the length of this line is square root of leg squared plus leg squared. And the same thing here. Very good. And I have two of those. So I'm going to say h minus y is the length that the power line is joined. And then 2 of the x squared plus y squares to the 1/2. Is that my primary equation?
Yes.
That is what I'm trying to minimize. I'm trying to minimize the length of line I have to use because that cable's expensive. Do I need a secondary equation?
Doesn't look like it.
I have to keep making a mental note that x and y are both constants, or excuse me, x and h are both constants. So really that is only in terms of one variable. Y is the only variable.
So why is it your primary equation again? Am I right?
Because it's what I'm minimizing. And so I'm ready to differentiate the derivative of the length with respect to what variable? The only variable, y. Not sufficient to say just L prime here.
Why is there only one equation? I know you just explained that. Can you explain it again?
That's okay. Let me say it again for anybody who needs it. This problem has 3 letters in it, but 2 of those letters are not variables. These power plants are already built, so X is a constant. That power plant's already built, so Y is a constant.
So if we have more than one variable,
Oh, excuse
we
me.
have to have. You have to have two.
I just misspoke. Let me correct myself and then answer your question. X is a constant and H is a constant. The only variable is how far I run the power lines along side by side before I split off. And so the answer to your question is I only need one equation because I only have one variable. The only variable is Y, even though X and H are letters, they're not variables.
Okay.
All right. So what is the derivative of H minus Y?
-1.
H minus Y.
Derivative of H is a constant, so the derivative of a constant is 0. The derivative of negative Y with respect to Y is just -1.
That would be -1 Y.
I don't have to have a Y prime because I'm differentiating Y with respect to Y.
Okay, gotcha.
It's just like differentiating X with respect to X. It's just 1. The derivative of 2 ugly to the 1/2. 1/2 times 2 is 1. Same old ugly to the -1/2. What's the derivative of the ugly with respect to Y? 0 plus 2Y, or just 2Y. Because the derivative, X is a constant, and the derivative of a constant is 0.
Oh.
So, let's see. That is -2Y over the square root of X squared plus Y squared. Where did you know what? I multiplied -1 times 2Y instead of -1 plus 2Y. I can fix that. I'm going to just, when I set that equal to 0, I'm going to go ahead and add 1 to both sides.
Get all that.
And then what?
Solve for y.
How do I solve for Y?
Multiply both sides by square root of x.
Clear out the fractions. Then what? Square both sides. Subtract Y squared from both sides. Divide by 3. And then take the square root of both sides.
You'd only need the positive value for that, right?
Right. Since we're talking about a distance, and distance can't be negative, We don't have to have plus or minus square root of x squared over 3. Now, that's all we can do because we weren't given how far these two plants actually were from the origin. If we were given these distances as numbers rather than some number I don't know, then we could actually come up with a number for how many feet y needs to be from the power plant. But since we don't know x, all we can do is give an expression for y in terms of x. Let's see, it said find y. Yeah, the direction said find y, and we have. So if somebody comes back and tells me that these two plants are each 80 feet from the origin, then I will say you need to make the split from the power plant 80 divided by square root of 3 feet away from the power plant. All right.
Can I ask a quick question?
Yes, sir.
Is there a rule that you can give us to know when to do the derivative?
Yes. I think I just thought of a note that might help answer a question from Kayla and your question. The primary equation always represents the quantity to be optimized. And optimized could be maximized or minimized.
Right.
So far, so good?
Yeah.
Okay. Here's the answer to your question.
Is that just when you simplify it as much as you can?
Yes, that's just making life easier on yourself. Let's see. Primary equation represents the quantity to be optimized. Get it in terms of only one independent variable and simplify.
Okay.
In the second equation, we only need to get very simple one variable.
Yes, actually, let me tell you why this note makes so much sense. In retrospect, why this note makes sense. It makes sense that you're going to differentiate the equation that you're trying to optimize. If you're trying to maximize the volume, then the volume is what you need to differentiate. And the volume is going to be your primary equation. The only reason you may need a secondary equation is because your primary equation may have more than one independent variable. And the secondary equation helps you get it to only one independent variable before you differentiate. Simplify isn't required, but it makes your life a lot easier to simplify before you differentiate. Did that help?
Yeah, can you leave that there for 1 second?
Get primary equation to one variable, simplify, and then differentiate.
Beautiful. And then set equal to 0.
Alright.
All right? Good question. Anything else? All right, we're fixing to be told that we have 2 minutes left. I don't mind attempting to answer about a question from the homework in 2 minutes, but before we do that, let me make sure you know you only have 5 problems from the homework, and they are right here, these 5 problems. And I will most likely take them up Monday when we get back from Easter break, because I need a couple more homeworks.
And how many zeros do you drop from it?
I promised to drop 2. I'm trying to take up at least 12. So if I count drop 2, then I have 10 that count as a test grade.
Okay, have you dropped any yet? On what you
No.
put on?
Okay, let me make that clear. The homework average that I posted in Momentum, that's without dropping anything. So if you have even 1 0, that significantly affects your homework average until I drop 2. As soon as I drop 2, everybody's homework average is going to take a zoom upward. Any other questions? Do not forget your best friend here. The source of all odd, not just odd answers, but solutions to odd problems, because you're not going to be able to ask me everything you want to ask.